Everything in the universe is made up of building blocks called chemical elements. They join together to form everything from this dust to entire planets. But what are those elements and how are they organized? Let's find out together in this episode all about the periodic table. Everything is made of matter, and atoms are the smallest unit of matter. An element is a material that is made from a single kind of atom and cannot be broken down into a simpler substance. For example, iron is an element, so every atom in these iron filings is the same, just the smallest form of iron possible. Even this tiny speck of iron contains billions or even trillions of atoms. A trillion atoms grouped together is about the size of a period at the end of a sentence. Inside each atom are much tinier parts called protons, neutrons, and electrons. The number of protons in an element's atoms is what makes that element unique. These unique properties are how elements are grouped together on the periodic table. But before we get to that, let's rewind a bit, or a lot, to 1869 to see where all of this organization started. In 1869, a Russian chemist named Dmitry Mendeleev tried to organize elements into a grid or table. At the time, only 65 elements had been discovered, and Mendeleev decided to order them by weight or mass. He recognized patterns in how the elements behaved, so he decided to group elements with similar properties or reactions in the same column. The patterns were so clear to him that he left gaps in his table where he knew undiscovered elements must fit. He even named some of these elements and predicted what they would be like. Scary smart. Then, in 1913, another chemist named Henry Mosley discovered why the elements are different from each other. Their atoms have different numbers of protons, which led to the creation of the atomic number and the version of the periodic table of elements that we have today. Before we get to the entire periodic table, let's zoom in and see what information is contained in each element cell, or each of the boxes that make up the periodic table. Each element is assigned a chemical symbol, which is one or two letters. The first letter is uppercase, and the second letter, if there is a second letter, is lowercase. For example, hydrogen is represented as H, while helium is represented as He. An element's chemical symbol can be quite different from its name. This is because many chemical symbols come from other languages, mainly Latin or Greek. For example, Au is the symbol for gold because it comes from the word aurum, which is the Latin word for gold. And this W comes from the German word wolfram, but in English, the element is called tungsten. Every element has what is called an atomic number, this number on the top, which is the same number as the element's number of protons. The number on the bottom is for the element's atomic mass. The atomic mass tells us how massive this element is compared to hydrogen. If you look at hydrogen's atomic mass, it's 1 in atomic mass unit. If you look at oxygen, its atomic mass is roughly 16. This means that an atom of oxygen is about 16 times more massive compared to an atom of hydrogen. Sometimes you'll see the element's full name listed as well. The names of the elements change depending on the language, but the chemical symbols remain the same universally. If you're still here liking this video, let us know. And hit that subscribe button so you never miss an episode. The periodic table looks like this. It shows 118 different elements and reveals which elements are similar to each other. Each box represents one element. The periodic table is organized by row and column. Each horizontal row is called a period, while each vertical column is called a group or family. The elements are laid out in order of how many protons their atoms contain. Hydrogen is first because its atoms have 1 proton. Elements that belong to the same group or column share similar physical or chemical properties. If you break down the elements into 4 groups, This is what the periodic table will look like. Here we have the metals, nonmetals, metalloids, and rare earth elements. These groups can be broken down even farther, but this is as far as we're going to get today. Some common metals are iron, like these iron filings from earlier, or copper, like the covering of these pennies. Potassium and lithium are also metals, but are reactive metals and produce colorful flames when they're burned. Then there are nonmetals like helium that allow these balloons to float, or sulfur that gives skunk spray that special smell. 78% of the atmosphere is nitrogen. And chlorine keeps our swimming pools safe to swim in. Metalloids are what they sound like, elements that share mixed properties of metals and nonmetals. Silicon is crucial for cell phone and computer microchips. Arsenic is a poison and used in pesticides. Cerium is the most abundant rare earth element in the Earth's crust. It's used to help chemically transform toxic emissions from engines into less harmful compounds like water vapor and carbon dioxide. If you want to learn more about metals, nonmetals, metalloids, or rare earth elements, you can check out this video. These elements together make up everything from the air we breathe to us. So the next time you enjoy a bright balloon, you can thank helium. Or smell a particularly bad emission, you can blame sulfur. And if you want to learn more science, you can check out this video now.